So today's the final day of this project. We're going to rivet all the separate pieces together and make any final adjustments that need to be made, and then we'll put it on the door and hopefully it'll work all right. The first part I'm going to work on is the spring, and in order to figure out the location for the spring, I need to know where the spring comes into contact with the latch bar. So here I have the tumbler and the latch bar sitting on the back plate, and I'll be able to use that to scribe a line to let me know where the end of the spring is going to be contacting the latch bar. The spring also has to fit underneath the top leg of the cover plate on the inside of the latch, so I need to put that in position so I know where that is as well. And then it's just a matter of bending the spring into position. You can see here that I have the tip of the spring falling below the line for the top edge of the latch bar, and I've done that on purpose. When I install the latch bar, I'm going to need to lever up on the spring, so that's going to preload the spring and put a little bit of tension in the latch when the latch is in the closed position. When you're transferring a paper pattern to a piece of sheet metal, it's really important to transfer all the information onto that piece of sheet metal. I didn't do that here, and it would have cost me a lot of time if this latch was going somewhere else. It's going on my door, so I'm not going to worry about it. But what I didn't do was transfer the location for the mounting holes onto this back plate. So you can see that this spring is sitting a little too high, and I'm really not going to have room to put the corner hole that I was planning on putting above that spring. I was concentrating on the curve of the spring, trying to get a nice line, and as a result the spring shifted up higher than I had originally intended, and I just totally forgot about that hole. When I'm installing parts like this that have more than one tenon that hold it into position, I usually start by cutting one hole, dropping one leg into that hole, and then using that to lock in the position so I can scribe the other location. And then I drill a series of small holes and clean it up with a slot punch. This is the back side of the back plate, and this is one of the holes that the spring is going to get mounted to. And before I can mount the spring, I need to bevel out the edges of this hole so I can hammer a flush rivet on the back of this plate so it sits flush to the door. Now this is going to look a little rough because my head is usually where the camera is right now, so if I do this normally, you're not going to be able to see what I'm doing. So fortunately, it doesn't have to be neat. I just need to make some room for the head of the rivet. I'm getting ready to rivet the spacer block to the spring, and I'm going to be using flush rivets to do that. A flush rivet is a rivet where the head of the rivet is sitting below the surface of the material. And that allows you to file the top of the rivet head flush to the surface. And if it's done right, the rivet becomes invisible. The key to making a successful flush rivet is to counterbore the surface of the material. The hole created by a counterbore has vertical sides that are parallel to the hole. A countersink, on the other hand, has a hole that is V-shaped, and that won't work for this application. Now, even though it's important to understand the difference between a counterbore and a countersink, you don't need any special equipment. I created these counterbores by simply drilling a slightly oversized hole, and I just made sure that I didn't go all the way through the material. I also counterbored the underside of the spacer block so I could create a smooth surface for the latch bar to ride on. Of course, I'm not going to be too concerned about how that looks, it just needs to be flat. When I'm hammering a straight rivet, I usually alternate between the front and the back side of the rivet until I've upset a slight bulge on each end of the rivet. When you're creating a rivet head inside of a counter bore, you have to make sure that you're always driving that rivet straight down. You want to bulge the sides of the rivet out so that they fill the counter bore. And you want to make sure that there's a great deal of pressure being created from the rivet on the edges of the counter bore so that all of the cracks and crevices around that rivet are filled. If you hammer too quickly or start rounding over the rivet head the way you normally would, you're going to stop filling that counter bore, and if you don't fill that counter bore all the way, when you grind the surface, you're going to see gaps or a line around that rivet. So here's the first one done, and I just need to repeat the process for the second hole. Everything else on this latch gets riveted together with just standard rivets. I always use straight rivets. I like the look of the hammered head rather than the round head commercially made rivets. I just cut the bar stock for the rivets from common nails. They're certainly plentiful and they come in a good range of sizes. And then once that rivet is set, I'll drill out the second hole and just repeat the process until the whole thing is fastened down. Working with a countersink on the back side of the plate, and normally when I'm doing these rivets, I'll just rivet the back side just enough so it fills that countersink. And then I'll drive that part of the rivet flush to the back plate and hold that right up against the anvil and finish the front side of the rivet. I made the rivet for the latch bar out of a small bolt. I just flattened out the head of the bolt and filed it round. Once the latch bar was riveted in place, I just stuck the whole thing back in the fire so that I could work the latch bar back and forth to free up the rivet. And here's the spring riveted into position. And then of course I use the same process to rivet the cover plate into position. And here again I'm drilling and riveting one side, and then once that's set I'll drill and rivet the other side. Here I've drilled a hole for the nut that's going to be holding the handles in place. That's going to allow me to use an Allen wrench to tighten the nut down. Before I located that hole, I did all the final fitting. I made sure that everything was right in the way I wanted it, and then I tightened that nut down as hard as I could by hand. And then I located the hole so that it was parallel to the back handle. And I figured if I did that, by the time I tightened it fully, that hole should be pointing downwards so you wouldn't see it. Hi, I'm Dennis and thanks for watching. If you like this video, by all means give it a thumbs up. If you want to support this channel, you have a couple of options to do that. The first, of course, is to just subscribe. Secondly, if you have any suggestions or photographs of things you'd like to see on this channel, send them along and I'll do my best to turn them into a video. If you want to lend your financial support, you can do that in a couple of ways. First, if you're interested in making an ongoing contribution to this channel, just click the Patreon icon and it'll take you to my Patreon page and you can donate whatever amount you feel comfortable with. If you want to make a one-time contribution, just go to my channel homepage and click the donate button in the banner. So thank you for your support, and with your help I'll be doing this for some time to come. I'll see you next time.